Okay, in this video we're going to look at the concept of functions, and there are several ways to define a function, okay, depending what book you have or teacher you have. Okay, the one I go with is a function is a relationship in which each input has at most one corresponding output. So in terms of order pairs x, y, we say that each x corresponds to at most one y. Okay, we've all seen equations such as y equals 2x plus 3. Is this relationship a function? And explain. Okay, so it's basically asking you, does each x have at most one corresponding y value? And what that's essentially saying is, if I give you a value of x, how many answers will you give me for y? Okay, if you only give me one answer at most, then we have a function. Okay, so for example, let's just say x equals 0. 2 times 0 would be 0 plus 3 is 3. Okay, you don't get two different answers when x equals 0. If x equals, say, 5, 2 times 5 is 10, plus 3 is 13. So when x is 5, y is 13. You don't give me more than one answer for the x value of 5. Okay, so is there any number you can substitute in for x where you get more than one answer for y? Okay, well, there isn't one. Okay, there is no value for x that you substitute it in, and you get more than one answer or two different answers. Okay, so here to sketch a quick graph of this. Okay, y equals 2x plus 3, should recognize that as linear with a y-intercept at 0, 3. Okay, so there's a y-intercept, a slope of 2, means you go up 2 to the right 1. So it looks something like this. Okay, and on a graph, what it's saying is, if you take an x value of 0, you only get one answer of 3. If x equals 1, okay, so if x equals 1, 2 times 1 is 2, plus 3 is 5. That's only one value on the graph. Okay, and I already said x equals 5. If x equals 5, 2 times 5 is 10, plus 3 is 13. You only get one answer on the graph. Okay, there's never any x value that you substitute in to get more than one y value. Okay, so do we have a function? Yes, because each x has at most one corresponding y value. Okay, so part B, does that mean that all lines will be functions? Okay, so what I suggest is pause the video for a minute and think about that, and think about any line that you can draw. Would that be a function where each x has at most one y? Okay, and I'll go ahead and answer it now, but I would suggest you pause the video and think about it. Okay, so when you draw lines, as long as they have a slope like 2 or -2 or 3, okay, then you're going to have a function. Okay, so when you think about drawing lines, what can they look like? Well, lines can look like the one up above here, okay, where that would be a function. If the slope was 3 instead of 2, it would just be a little bit steeper. If the slope was 1/2 instead of 2, it would be less steep. Okay, but each x would have at most one y. Another way to draw a line would be a negative slope, and that'd be similar, a similar explanation to up here. Okay, each x, like here, like if x is say -2, you know, with only one value for y. Okay, so a negative slope, okay, would also represent a function. Okay, the two special cases of lines, what if you drew a horizontal line? Like just say like y equals 2. Well, if x equals 1, y equals only one answer. If x equals 2, you only get one answer. If x equals -1, you only get one answer, and so on. So a horizontal line would be a function. If you draw a vertical line, okay, the only other possibility of what a line would look like, other than a positive slope, a negative slope, a zero slope, okay, horizontal lines, remember, have zero slope, or a vertical line, let's just say I drew it here at x equals 2. Well, now, does each x have only one y? Well, when you look at the points on this line, a vertical line at x equals 2, a point right on the x-axis would be the point 2, 0. If you went up 1, that'd be the point 2, 1. Went up another one, that'd be the point 2, 2, and so on. So what you notice is, if I were to ask you, if x equals 2, what does y equal? You can give me more than one answer. You can say 0, 1, 2. You could say 2.7. You could say 0.5. okay, and so on. Okay, so here, a vertical line is not a function. Okay, so to answer that question, no, because vertical lines are not functions. Okay, I shouldn't have worded it that way. They're not functions. That's answering the question. Okay, because x has more than one y. Okay, so again, with a vertical line, x is the same value every time. Okay, like here, x equals 2, but the y values can be different. Okay, so vertical lines are the only lines that are not functions. Okay, so in question number 2, make a small table of values and sketch a graph with the following equations to determine whether each is a function. Okay, so in the first one, y equals 3 to the x. Okay, x is an exponent. Okay, so make sure when you put in your calculator that you get that right. And then y equals x squared, there the 2 is the exponent. And then y equals -3 and x equals 2. Okay, you're gonna do those in a table. Okay, make a table for each, and then sketch a graph of them. Okay, and I'll just remind you, I'm gonna do one of these, and then I'll put the answers up. Okay, so you can work on these and then check your answers. Okay, when you do y equals 3 to the x, okay, in the TI-30 calculator, remember to do that, you press your table button. Oops, okay, turn on first. Press your table button. Okay, and then enter your equation as 3, and then the exponent key is the caret button here. Okay, so 3 and then exponent, and then the x variable key right here next to the 4. That's your x variable key. Okay, and then press enter, and then this will tell you where your table will start. Okay, and generally what you want to do is you want to fit values that, if you had a grid, they'd fit on the grid generally between like -10 and +10 for your x and y values. But let's look at the table. Mine is just starting at 0, so you can type a 0 in there. The step means the table is going to go up by 1, and then automatic means it's going to actually list the values for you, and then press OK. So I have the points 0, 1, 1, 3, 2, 9, okay, 327, 481, and so on. If I scroll back into the negative values, okay, so remember evaluating negative exponents, that's where you take the reciprocal of the base. So 3 to the -1, you would do 3 to the first, which is 3, and then flip it. And then where -2, you do 3 to the -2, that'd be 3 squared is 9, and then flip it to get 1 9. Okay, take the reciprocal. Okay, so as you go more and more in the negative direction, notice the values keep getting smaller and smaller. Eventually they turn them into decimals in your calculator here. Okay, but that's getting very close to 0. Okay, so so my suggestion is make a table from maybe -3 to +3, and that should work out fine. Okay, so again, I'm going to suggest you pause the video, and put these in your calculator. Make sure you get the correct answers, and then I'm going to put the answers up. Okay, so pause the calculator. I said it again. Pause the calculator. Pause the video, and I'm going to put the answers up. Okay, so this is what the graph would look like. Okay, and the tables. Okay, with y equals 3 to the x. Okay, is that a function? Well, does each x have at most one y? So if you take an x value, do you ever get more than one answer for the y value? And the answer is no. Okay, as you trace the graph, you can see like if x is a negative number, like say -3, you can only get 1 point right here. If x is -1, you only get 1 point on the graph. If x is 0, you only get 1 point, and so on. Okay, so y equals 3 to the x, that is a function. Y equals x squared, okay, that's your basic parabola, your U shape. And what you might notice on this one is notice how the y values do repeat themselves. So 9 shows up twice when x is -3 or +3. 4 shows up twice when x is 2 or -2, and so on. Okay, but does that mean it's not a function? Okay, this is what confuses students a lot. does each x have at most one y? So if I asked you, when x is -3, what is y? What would you tell me? Well, if x is -3, what's y? 9. You only get one answer. It doesn't matter that 9 shows up again for a different x value. What matters is, when I ask you if x is -3, what's y? Everyone should tell me 9. If you're not getting, if you got -9 there, remember, you have to put your values, your -3 in parentheses when you square it. Okay, so -3 times -3 is +9. Okay, so is this a function? Yes. Let's just say, if we're looking at the graph, if x is, say, -3, if x is -3 right here, you only hit the graph at one spot right here. There's only one answer. If x is, say, -2, you only get one answer for the y value. It doesn't matter that those answers, the y values are showing up again over here. It just matters that for each x, like if x is +2, you only get one answer for y. Okay, so that is a function. The last two graphs are a little more complicated to figure out. They're the easiest graphs, but weirdest ones as far as looking at a table of values and trying to figure out what the table and what values will be in the table. When you have y equals -3, what that's saying is there's no x in the equation, so we don't care what x is. The y value has to be -3. So whatever x is, the y value had to be the same at -3. Now that is a function, because if I ask you if x equals, say, 0, how many answers do you give me for y? You only tell me one answer of -3. If x is -2, what's y? -3. Okay, so each x has only one y value. Okay, again, it doesn't matter what the y value is. Okay, it just matters that if I ask you if x equals a certain value, what is the answer for y? If you only give me one answer, then we have a function. Okay, so that's a horizontal line at y equals -3, and that is a function. And then x equals 2. Okay, now this I mentioned above. Okay, but we can look at a table of values. This one, notice that there's no y in the equation. So it's basically saying we don't care what y is. The x value had to be 2. So in your table, the only value you can have for x is 2, and the y value can be any number. Now I just arbitrarily chose these numbers. You can put any numbers you want in there for y. Well, now if I ask you if x equals 2, what's y? You could give me any of these values for answers. So the x value at 2 has more than one y value, so it's not a function. Okay, again, it's a vertical line. Remember, the vertical line is undefined slope. Okay, so moving on from this. Okay, the second page. Okay, now we're going to look at function notation. Okay, basically it's saying, how do you write a function? Okay, so return it to y equals 2x plus 3. We may use function notation to represent the relationship between x and y. We say f of x equals 2x plus 3, written as f parentheses x. Okay, so the way you say that is f of x. It's not f times x. It's not multiplication. Okay, it's function notation. F of x equals 2x plus 3. Here, y is a function of x, and y equals f of x. Now, essentially, all that's saying is that in place of y equals, you're putting f of x. Okay, so whenever you see f of x, that's just another way to say y equals, or the output equals. So each value substituted in place of x results in only one y value. So each x results in or gives you only one y value. Function notation is an easy way to evaluate a function for y when given various values of x. Note that any function will pass the vertical line test. Now that's what I was saying on the first page. If you were to draw a vertical line anywhere on our graph, okay, so if you take a ruler, okay, so pretend the side of my ruler is a vertical line. As you move across the graph, okay, so looking at the exponential if you're 3 to the x, okay, as you move across, does that side of the ruler ever hit the graph at more than one place? Okay, if it does, then we don't have a function. If it only hits at one place at the most, then we do have a function. Okay, so this one is a function. Looking at the parabola, again, the vertical line, as you move from left to right, you only hit in one spot each time. Okay, so we have a function. By the time you get to the vertical line, well, it's not hitting anything here, but once you get to the vertical line, it's hitting every point on that line, so it's hitting more than one place. So that is not a function, because we're hitting more than one place on the line. Okay, so that's all the vertical line test is if you have a graph, it's one way to determine if you have a function or not, is use the vertical line test. Okay, so number 3. Okay, it says given f of x equals 2x plus 3, evaluate each of the following f of 5. Well, all it's doing here is, notice how our function is f of x, and x is in the parentheses, so your input, x, is in the parentheses. Well, now what's in the parentheses? A 5. So all that means is, everywhere you see an x, you're going to put a 5. Okay, that's all it means. So f of 5 equals 2 times 5 plus 3. So f of 5 equals, well, 2 times 5 is 10, add the 3 is 13. Okay, so when x equals 5, y equals 13. The next one, f of negative 1. Now everywhere you see an x in our function, we're going to put a negative 1. So f of negative 1 equals 2 times negative 1 plus 3. So f of negative 1 equals negative 2 plus 3, which is positive 1. So when x equals negative 1, y equals 1. And then f of 0, okay, I just got to take a second and do that, and I'll put the answers up here, okay, just for the sake of time. Okay, so f of 0, you get 3. Now part B wants you to write them as an ordered pair. Well, again, we're in the first one we put 5 in place of x. So when x is 5, the output, or y, is 13, which gives you 5 comma 13. Okay, and then the other ones are there, negative 1, 1, and 0, 3. Okay, and the next one, number 4. Okay, this is just giving you a different name of a function, g of n, instead of f of x. So now the function's name is g instead of f. And instead of x for the input, we have n. Okay, so notice we have 5 minus 2n, okay, where n is the input. So now g of 1 is just saying everywhere you see an n, you're going to put a 1. Okay, so take a minute and try these and see what you come up with. And I'm just going to keep on going on with the answers for the sake of time. You'll notice in part C, the g of t, we don't know what t is, it's a variable. But the idea is still the same. Everywhere you see an n in your function, because your function's name is g of n, you're going to substitute what was in the parentheses, in this case t. So you just do 5 minus 2 times t. Okay. We can't actually evaluate that because we don't know what t is. Okay, and then you see them written as ordered pairs, 1, 3, negative 2, 9. I should have written the last one as an ordered pair. It's a little bit awkward to write it, but the input was t. So as an ordered pair, we have t, comma, the output is 5 minus 2t. That would be the ordered pair for that one. Okay, it looks a little awkward, but since we don't know what t is, we can only have an actual number for it. Okay, and then try number 5. Okay, here we have a quadratic equation. Okay, because we have the x squared in there. Okay, but h of 2 and h of negative 2, you're just going to substitute those values in for x, and then evaluate. And then 4n, this will be a trickier one. In this one, everywhere you see an x, you're going to replace it with a 4n. Okay, so again, my suggestion is pause the video, try it, and see what you come up with, and I'll put the answers up right now. Okay, on part C, okay, when you substitute the 4n, remember that was negative 3x squared. So in place of x, you're putting 4n. Well, when you do the quantity 4n squared, remember that really means 4n times itself. So 4n times 4n, which will be 16n squared. Multiply that by negative 3 will give you negative 48n squared. And then the 5 times 4n will give you positive 20n, and then bring down the minus 7. Okay, so there's the answer for that one. Okay, the last part of this, question number 6. Okay, here, they're worded a little bit differently. Given f of x equals 3x minus 8, we want to solve f of x equals 10. Well, now this one, notice they're not giving you a number in the parentheses like they did up here. Like h of 2 meant you put 2 in place of x. Well, here, with f of x, they're not giving you the number in the parentheses. So this does not mean that x equals 10. Remember that f of x is a fancy way of saying y equals. Okay, so really what they're giving you here, when they say f of x equals a number, like 10, they're saying that the y value is 10. Okay, so we're not going to put 10 in for x, we're going to put 10 in for f of x or y. Okay, so to do that, in part A, we set up this equation. Instead of f of x, we have 10 equals 3x minus 8. Okay, go through and solve that by adding the 8 and then dividing by 3. Okay, and again, I'm going to suggest you pause the video and try part B also, and I'll put the answers up right now. Okay, when you get to the bottom 3 in C, D, and E, okay, same idea. They're giving you, in part C, they say that g of x equals negative 6. So that doesn't mean that the x value is negative 6. It means that y equals negative 6. Okay, so when you substitute that in, we have negative 6 equals x over 4. To undo dividing by 4, you multiply each side by 4. So you get negative 24 for x. Okay, part E and F are a little bit trickier. Okay, these are ones that we haven't solved algebraically. We haven't done those algebraically yet. Okay, but when you look at setting up the equation, 16 equals 2 to the x, okay, I want you to think about that what exponent do you put on a 2 to end up with 16? We'll just go through some values, like 2 to the second is 4. 2 to the third would give you 8, because 2 times 2 times 2 is 8. Multiply by another 2 would give you 16. So how many times you have to multiply 2 by itself to get 16? Okay, it's x equals 4 times. Okay. And then the last one, part E, solve p of x equals x squared if p of x equals 16. So again, p of x, right here is a fancy way of saying y equals 16. So 16 equals x squared. Now when you square a number, it means you multiply that number by itself. So you need to think about what number or numbers can you multiply by itself to get 16. Well, most people would recognize 4, because 4 times 4 gives you 16. But also, if you square negative 4 times negative 4 will also give you positive 16. Okay, so that one actually gives you 2 different answers. Now, this is something we're going to solve algebraically coming up soon in the next few weeks. When we start quadratics more formally. Okay, but we can think our way through that one and recognize that if you square 4 or negative 4, you end up with positive 16 for an answer. Okay, so that's the first part of looking at functions, the definition of a function, and how to evaluate functions given an equation.